EIGRP continues. Okay. Now, remember, this is a very fast, simple, easy protocol for you to learn. Okay. Technically, RIP is the easiest to learn. EIGRP is a little bit harder. Okay. Then we get where the big boys are, which is OSPF, and you're going to you're going to be bombarded with information. Okay, and at some point you're going to say with OSPF, what the hell, man? I mean, does all this really matters? And it does. You're going to start realizing that um, the information just doesn't stop. Okay, so from that point, OSPF will either make you or break you from the sense of you continuing your studies from an aspect of are you really in for this as a lesson of a skill set, okay? Or if you're in here just to pass an exam to get paid, okay? Because I'm going to tell you, all right, um, you're going to limit yourself being that aspect and using that mythology as far as how you're going to succeed. Okay, so remember our K values, okay? Those K values are used with bandwidth and delay by default, but we have load and we have reliability, okay? Now, my routers obviously are not on, so let's find out. Okay, here we go. Interface command right here. Okay, so our reliability, all right? Reliability is the reliability of the link. So if my router's been up for a year, okay, and that link has gone down 50% of the time, then most likely I will have a 128, okay, reliability out of 255. Now, that might be over a period of time, okay, and we could always go back and reset those counters, okay, all right, because remember your interface might be having bad packets, okay, or input errors, which you see down here, okay, but if you're looking for current errors, you need to reset those counters because those errors on that interface can be years prior. Okay, you would know unless you reset the counters and saw new errors coming in. Make sense? Okay, but when I see a reliability of 255 out of 255, that is telling me that this interface has stayed up and has been good. Okay, but that doesn't mean it's without errors. Okay, all right, and it doesn't mean it's without collisions. Okay, and it does not mean it's without problems. Does that make sense? It's just the reliability of the interface. All right. Now, that does not mean administratively shutting down. Okay. All right. It could mean a flapping link. It could mean that the interface dies for whatever reason or goes in amber state. Okay. So that is your reliability. And your load is your load of your interfaces. The higher the load, the higher the number on the left hand side. 255 out of 255 load means it's saturated. All right, you're at 100% capacity. Okay, and your MTU. Hold on. Okay, your MTU. Where the hell are you? There it is. Okay. All right. Okay. That's just your MTU. Okay. Based on the value of it is, if you set it to something lower, it changes the way your algorithm is making the metric. Okay. It's just math. Okay. All right. Even OSPF, when it's doing its thing, it's math. The algorithms are just math. That's why we call them algorithms. Okay. All right. Now, remember those routes and those backup routes? Well, they have names. Okay. The main route will be the successor route. Okay. I mean, out of a contents, a contest. Who wins as a successor? Okay, all right. I mean, simple as that. Okay, all right. The successor is the best route in the network or in the contest, right? All right. This goes in the routing table. Now, your backup route is in the topology table, okay, not in the routing table unless you're going to do load balancing slash load sharing, okay? All right. And the feasible successor is the backup route, is the very next best route. Remember, the cool thing about EIGRP is when I lose my successor, my feasible successor automatically kicks in without running the EIGRP algorithm. This saves on CPU usage. Okay, whenever, like when you have a flapping route. Imagine a flapping route going up and down, up and down, up and down, up and down. Okay, all right. Imagine how many times the EIGRP is going to be ran every time that interface goes down and up. Okay, it's twice per cycle. All right, so we don't want that. All right, so that's the cool thing about having a backup route. Now, okay, I don't know why I put uses administrative distance and feasible distance, because we just said that. Not sure why I wrote that, but nonetheless, we're moving on. Okay, now, here is the interesting thing. And I'm going to say it, and I'm going to leave it alone, okay? All right, because it does take your own research to possibly get this stuck in your head, okay? So do more reading on the feasible successor with EIGRP, all right? Remember, this is your journey, not mine, okay? I'm just helping you out, all right? So now, the administrative distance of the feasible successor must be less than the feasible distance of the successor. So now, okay, let me see if I explain this correctly. Let's do this here. Stop doing that. Okay. The only way to do this is actually look at the output of the topology table, and I might have to start the router for that. And it looks like I do, because I don't remember the last time I actually ran that. Okay, so let's get this started. Okay, alright, while they are booting, you know what we're going to do? I'm going to see if I can find okay, in Cisco Enhanced, which is EIGRP, a feasible successor is a backup route. This means that the administrative distance of a potential successor route must be less than the feasible distance of the successor. Okay, feasible successor is the lowest calculated metric to reach a destination. Okay, so that's not correct. Okay, it's not the lowest. Okay, it's the second in line. So that's not really a correct statement from my take on it. And it's not telling me really what a feasible you know what? Probably because I'm not looking up the correct keyword. represents the lowest metric. That's the same thing. All right, let's see if we can get better definition. Okay, let's go back. Feasible distance is the lowest distance to the destination experience since the last time. I'm having a hard time with that definition. And you know what? Hang on for 1 second. I'm gonna pull out one of my books for this. Hold on. Okay, all right. I'm gonna pause the video and do some research and in my books. Okay, all right. Never throw away your books. Never resell them. Keep them in your library. Okay, they are reference books. They are part of who you are. All right. So now let's go ahead and pause this. Okay, it's funny because the book, which I still have another book to go through as well. If I really wanted to nail this this thought, okay. And the thing is, the book is always talking about the feasible successor, but it's not talking about how a router is dictating the value of the feasible successor. Okay, so I'm going to explain it the best way I can. Okay, all right, and let's go ahead and take a look. Okay, so again, I did not save this config unless this is not saving correctly. So what we're going to do is save that. Now I know that loopback should come back, and if it doesn't, I know it's something wrong with the NVRAM. But who cares? I can always reconfigure it. Section router. Okay, yeah, that's not there either. Okay, EIGRP is up. Okay, now here's the thing here. Show IP EIGRP topology. Okay. Okay, so now, all right, for FA 192.168.1.0, okay, this is the successor, and the feasible distance is 28.160. So, show IP route. Okay, so this is the metric. Okay, 156.160. Okay, the feasible distance is 28.160. Now let's take a look at router 1, router 2, because router 1, and I can't believe this is not described in the book. Okay, router 1, and let's see, do show IP route. Okay, so the route for actually, you know what? Let's take a look at the 2 network, the loopback interface. Okay. Okay, so for 2.2.2.2, okay, the feasible distance is 128.256. Okay, in this topology, 2.2.2.2 is 128.256. Okay, so um, this is crazy. Okay, so I need to find the link. Okay, okay, you know what? Okay, all right. Okay, there's a struggle here because I'm not getting the information to give you a direct link, but the feasible successor, or the feasible distance, I'm sorry, is a measurement of its distance to its neighbor, okay, and the administrative distance of the neighbor for that particular route, okay. Um, but that's not really the case because we can have an administrative distance of 90 going to 156,000 feasible distance. Okay, so it must be the metric from the neighbor, and it adds on to that neighbor. Now, that's where we stop because I can't explain this in a way of being accurate, and I can't find the documentation on it. So we need to come back to that, okay? And I'm tapping out with failure, okay? Because I'm surprised that at a CCNP level that this is not explained in a book. I guess I have to go to Cisco documentation, okay? And we're going to try one more attempt, okay? That's feasible. Okay, let's see what this says. And once again, this is not Cisco's site, but let's see if they're accurate. And let's go ahead and do a find. Okay. To properly discuss feasible conditions, you must understand the following: successor, distance, feasible distance. Okay, in the topology, we have 4 EIGRP routers, despite there being blah, 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 blah. Each link also has leak costs. We will use these calculators to each feasible distance and reported distance. Okay, now that's starting to sound rememberable. Feasible distance to 9.9.9 from router 4's perspective is 256. Now, how do I see that? Okay, and that's the missing link here. How do I see? Because that is, and because that's what we need to look at. We need to look at routers 2 feasible distance. Because what's happening is router 2 has a feasible distance to the loopback of 2.2.2.2. When it shares that route with EIGRP over to router 1, it's giving router 1's feasible distance to that loopback of 2.2.2.2, and router 1 will add on to that feasible distance of its distance to router 2. Does that make sense? Okay, that's the missing link right there. All right. So how the hell do we find out what that feasible distance is? And you know what? show IP EIGRP 1 topology, and let's take a look at the route. Okay, 2.2.2.2 show IP interface brief. Yeah, what are you talking about? It's not there. Okay, what does this say now? IP prefix. Oh, okay. All right. Okay, there's my feasible distance. Okay? So the feasible distance, that's the missing link right there. Okay? All right? For some reason the command just came to me. So now let's go back over to here. Okay? Failure becomes success. All right, so show IP EIGRP topology. Okay? And now our feasible distance is here. Okay? All right? And it's the same over here, which again, that is not yeah, you see how router 3 maybe I'm not having enough routers. But notice that router 4 has 256, but then router 3 adds to that particular feasible distance. That's how it's supposed to work. That's not what I'm seeing. Okay? This to me, this from a memory perspective is accurate, but that's not what I'm seeing on the routers. I might have to bring a couple more routers in here and see how they react with each other a couple hops down the line. Okay, now, so that was a missing link though. Okay, and it's in the topology specifically to a route that gives me the information that I want to see. Okay, but from EIGRP's perspective, the feasible distance is 128,256. It should not be the same on router 1. Okay? If I had a third router, which I'm going to hook up here before the next video, most likely, we would take a look at that. Okay? So, nonetheless, you got to understand that your successor becomes the route, the feasible route. Now, keep in mind, we're talking about feasible successor, which is the backup route, okay? But what we're talking about now here is the feasible distance, okay, to actually determine what becomes a feasible route, okay? Now, the variance command. The variance command is as simple as this, okay? If I have multiple links, now I definitely got to have a couple more routers put in here. If I have multiple links or multiple paths going to the to a route and they're not equal, okay, because by default if it's equal you'll have two paths in the routing table, and it's not equal, okay, in order for both those paths that are unequal paths to go into the routing table is use the variance command. So if I say variance 2, I'm going to say, look, on an average, any route that has a metric that is twice as bad, go ahead and share across both those links. Okay, even with that worst, that horrible metric. Okay, now, do your own research. I'm not saying that's how it does it. Okay, the variance numbers do not literally split it in half. But, okay, it's kind of, I don't know if it's kind of rule of thumb or just how I perceived it at the moment. Alright? Okay? What are passive and active routes? Okay, that I'm going to have to look up again myself. Man, Wow. Hey, this is bringing back some memories. So it's a good thing I'm doing this. Okay, so now I gotta go back. Auto summarization. We gotta do some manipulation of the bits. So that's gonna be its own video. Okay, so but passive and active routes, I don't have to look that up. Okay, so at this moment, this is the conclusion of this section. So be strong, be determined, be just Cisco.